Okay, so for this video, we'll be solving moments question that involve two pivots. Okay, so first of all, how do we know that it is a moment question, that we need to use a principle of moments, or we need to calculate moment? So first of all, look for the keywords such as pivot. Okay, sometimes it may not be pivot, sometimes they will call it a fixed point. Okay, so for this question, how do I know that there are two pivots? Because firstly, this rod, it has weight. There's going to be weight, right? And why doesn't this fall? Is because it's supported by the cable P and Q, right? So I can also take that this is the pivot P and this is pivot Q. Okay, so we have two pivots, right? So to solve this kind of question, it is important to remember that it's important to know that for two pivot question, firstly you assign one pivot as the pivot. Okay, one pivot as a pivot. So later on I'll be assigning either pivot P as a pivot or pivot Q as the pivot. So only assign one pivot as the pivot, right? And bear in mind that any force that passes through the pivot will have zero perpendicular distance. Therefore, it will have no moments. So it doesn't mean that there isn't any force. There is a force, but as long as a force passes through the pivot, there will be no perpendicular distance and therefore no moments. So this is important. Please read through this and think about it. So now I will assign P as a pivot. Okay, so I'll be using green color for P as pivot. Okay, then let me erase this. Okay, so this is actually our first step in our 6-step solving moment question. Assign or find a pivot point. So now we choose P as a pivot, although Q is also help supporting the rod. Right, let's read the question. This is a uniform iron rod. Okay, the length is 50 cm. So if I put it into perspective, over here we have a distance of 5 cm and over here we have a distance of 10 cm. So the distance between P and Q is actually 35 cm. So you write this down first. We will be using it later. Okay, then we also take note that the mass is 5 kg. So if the mass is 5 kg, we have to convert it to weight because we are dealing with forces. We are not dealing with mass. So weight is using the formula mg. So W equals to mg. My mass is 5. It has to be a SI unit. G is 10. So 4. So my weight will be 50 Newton. And because it is a uniform rod, it will be in the middle of the rod. It will be in the middle of the rod. I know I haven't taught some of you about CG yet, but it will be in the middle of the rod if it's uniform. So let me write it down. Okay, so over here I wrote uniform means the CG is in the middle. That means the weight is acting in the middle and it is going to be 15 Newton. Okay, so step 2, how many forces are there? There are 3 forces. Firstly, we have an upward force called TP, or let me call it FP. I have an upward force of FQ, right? And these 2 forces are actually supporting the rod and not letting the rod fall, right? The downward force is actually 15 Newton. So how many forces are there? There are 3 forces. 3 forces are there. Okay, and they are force P, force Q, and W, which is actually 50 newtons. Okay, so once we have identified the number of forces, step 3, if you remember, it is finding perpendicular distance for each force. Okay, remember we took P as a pivot And bearing in mind, any force that passes through the pivot will have zero perpendicular distance. Therefore, Fp with P as the pivot, because Fp passes through the pivot, the perpendicular distance of Fp with reference to pivot P will be 0. Okay? And for Fq, it is a distance of 35 cm. Right? Now, for the weight, which is 50 Newton, the perpendicular distance is actually, because it is in the middle, right? So it must be at the 25 cm mark. So 25, and we take note that there's a 5 cm here. So for the 50 Newton, the perpendicular distance is 25 minus 5, which is 20 cm. Okay, it's a bit messy, but I say again, because it is a uniform iron rod, so the weight is in the middle, right? And in the middle of 50 cm is actually 25 cm. Okay, how far is this weight away from the pivot P? Is actually 25 minus 5, because there is this small little part of 5 cm here. So I take 25 minus 5, I get a perpendicular distance of 20 cm. And with that, actually the more difficult part is solved, right? Step 3, it is always difficult finding the perpendicular distance. So make sure you understand why perpendicular distance of Fp to the pivot P is 0, for Fq is 35 cm, and for weight is 20 cm. Okay, then now for step 4, finding moments. Okay, so moment of Fp will be Fp multiplied by 0. Anything multiplied by 0 is 0, right? How about moment of Fq? It will be Fq multiplied by 35, so we get 35 Fq. And lastly, because we have 3 forces, moment of weight will be weight, which is 50 multiplied by perpendicular distance of 20. Weight is 50 Newton multiplied by 20, we get 1000 Newton cm. Okay, so because we have 3 forces, right, 3 forces, we have found 3 moments, although the moment of Fp is 0, right? So we have found all 3 moments. So step number 5, assign direction. Assign the direction for each moment. So you will have to use my pen trick. That means you hold up a pen, hold up where the pivot is, which is pivot P, and then you apply each force, whether up or down, whether is it on the left or right of the pivot, and then you will be able to see is it clockwise or anti-clockwise. Okay, so for W, the direction is clockwise. For moment of Fp, it is 0, so no direction. For moment of Fq, it is actually anti-clockwise. So now, step 6. We can apply principle of moment. Why is it that we can apply principle of moment? Because it is balance, right? Not moving, not rotating, or stationary. Okay, so principle of moment states that at a pivot, right, we chose P as a pivot, the sum of clockwise moment about pivot P is equal to sum of anti-clockwise moment about pivot P. So you use the same pivot of P, right? So therefore I will have 35 Fq is equals to 1000. Therefore, after I calculate, Fq will be, so after calculation, my Fq is 28.6 Newton or 29 Newton according to the MCQ. Okay, so now how do I find Fp? How do I find Fp? Where did FP go in our calculation? FP actually disappear because remember FP multiplied by 0, I get 0 moments. And because we are dealing with the principle of moments equation, as FP multiplied by 0, FP will not be found in the equation. So this part is very important. Any force that passes through the pivot will have 0 perpendicular distance, will have no moment. So if I want to do, if I want to find FP, I will repeat the process again, okay? But this time I'll use a different color. I'll use Q as pivot, okay? Step 2 is the same. How many forces are there? There are still 3 forces, FP, FQ, and weight. So FP, FQ, and weight. Okay, so that was step 2. Step 3, finding the perpendicular distance for each force. Remember now we are using Q as a pivot, and FQ is actually passing through the pivot of Q. Right, now we choose Q as a pivot. So the perpendicular distance of FP will be 35 cm. It's no longer 0 because now the pivot is not at P. The pivot is now at Q. Therefore, the perpendicular distance of FQ will be 0. And for W, there's a slight change because if you were to take note of here, it's 25 cm. And I have 10 cm protruding here, so my perpendicular distance for W will be 25 minus 10 equals to 15 cm. Okay, so this is bearing in mind having Q as the pivot. Okay, therefore step 4, we calculate moment. Moment of FP is equals to FP multiplied by 35. Okay, I say this again because now we are using Q as the pivot. Okay, I hope the color can help you. Now FQ, okay, FQ is now having the fate of having no moment because the perpendicular distance is 0. For W, there's a slight change. It is now 50 Newton multiplied by 15 cm because now it's Q as the pivot. So I have 750 Newton cm. Okay, so how about the direction? Step 5. Let's assign the direction. Okay, and again there will be some changes because now Q is the pivot. So if Q is the pivot, then the moment of W will be anti-clockwise. Okay, this is now 0, no direction. Okay, for moment of FP, it will be clockwise. Okay, clockwise. So this is assigning direction, and because this is stationary, not rotating, we can now apply our principle of moments. Okay, so I will equate 35 FP to 750 clockwise equals to anti-clockwise. So upon calculation, I will get 21.4 Newton. So it's about 21 Newton if I want to fit it into the MCQ. Okay, so now we have calculated both FP and FQ, right? FQ is acting upwards with a force of 29 Newton, right? Sorry, FQ, not FP. FQ is acting upwards. FP is acting upwards with a force of 21 Newton. Okay, so if you add up the total upward force, it is actually 50 Newton, right? And remember, the weight is actually 50 Newton as well. So what could you have done to cut short your working? Okay, once I assign Q as the pivot, okay, I can find P. If I assign P as a pivot, I can find FQ. But their total upward force must be equal to total downward force. So I can just take the total downward force to subtract any of this to get the other force. Alright, so